Hi everyone, my name is Jess Larson and I am meshIQ's Events Manager. I would like to welcome everyone attending and we really appreciate you taking the time to join us. Today's Tech Talk topic is Enhanced Observability and Governance for your Kafka infrastructure. Just to let you all know, this Tech Talk is the 7th in a series of Tech Talks that meshIQ will be presenting monthly. At the end of this presentation, I will include links to watch past Tech Talks on demand if you missed any of them. Also, feel free to send any questions you have in the chat box throughout the presentation for the Q&A portion at the end of the webinar. Our speaker today is Scott Corrigan, VP of Technology Services at meshIQ.
Thank you, Jess, and thank you to everyone for joining today.
So Scott, what is the Kafka Summit? Can you tell us about what's going on at this event?
Well, the Kafka Summit is a live event that's hosted in person this year at the Excel London Exhibition Centre. This event takes place once a year, and it's the premier event for all DevOps professionals who want to learn about Kafka and streaming data. There's something for everyone. There's free 90-minute training courses that are offered on both days of this event that begin with an overview of Kafka, its core concepts, what Kafka is used for, provides an introduction to data streaming, and it concludes with best practices for developing applications with Kafka. There are breakout sessions each hour in the afternoon where experts talk about their experiences with Kafka and share best practices. There are more than 50 speakers presenting at this event from a variety of organizations, and many of them are end users.
Wow, there's over 1,800 people at this event. What is it about Kafka that has everyone so interested?
Well, there's a growing number of applications that are based on streaming data that need to process and move data in near real time. And Kafka stands out as one of the most compelling technologies for streaming data. Kafka is a system for high-throughput, reliable event streams. It supports event streams of millions of messages per second, and it stores those messages durably on disk. It replicates messages across multiple machines. The original use case for Kafka was website clickstream analysis. LinkedIn needed a better understanding of user behavior. They needed to know who was clicking on what in order to serve personalized and targeted content to their users. Kafka is also used in the modernization of legacy IT for updating applications and migrating data and processes to the cloud. It's also used for application integration. As more and more applications and cloud services are added, data silos start to emerge in organizations. Well, Kafka's event-driven data architecture is a way to connect those data silos. And lastly, real-time analytics, getting usable insights from data in real time instead of storing massive amounts of data in data warehouses. Kafka helps organizations to build event streaming platforms that collect and analyze events while data is in movement.
So can you tell us a little bit more about meshIQ? For example, what is the relationship between meshIQ and Kafka?
Well, meshIQ is an observability platform. It's for messaging, event processing, and streaming across hybrid cloud infrastructures. That's MESH, used as an acronym: messaging, event processing, and streaming across hybrid cloud. It's designed for application and integration DevOps professionals who need a single pane of glass, a way to manage and monitor the complex mesh landscape. That integration infrastructure, which is in its essence the digital nervous system of your modern enterprise. It delivers complete management, control, and tracking across the mesh. Message queuing systems like RabbitMQ or ActiveMQ are well suited for some applications. So for example, where one service asks another service to perform a task on its behalf. Well, Kafka is a good choice when it comes to logging events. So for example, a user viewed a web page, a customer purchases a product. Different tools are good for different purposes, and it's very common for modern applications to use Kafka for event streaming and a messaging system, or both in the same application. Now, there are 4 core functional domains of the meshIQ solution. There's governance, which includes things such as configuration and message management, as well as secure self-service for DevOps teams. Intelligence, which includes real-time monitoring as well as proactive alerting. Actions, which involves the triggering of automated actions that are based on events, and intelligent actions that are determined by machine learning. And finally, introspection, which performs analytics powered by historical data, as well as tracking and tracing of application message flows.
So Scott, what groups of people use the meshIQ solution?
Well, the meshIQ solution is designed to suit the unique needs of various stakeholders within an organization. People within different areas of responsibility, but who all need the right tooling to make their jobs easier to perform. So people who work in shared services, for example, they're responsible for the integration infrastructure. They're interested in middleware management and control. You've got application owners and enterprise architects who want to make sure that their applications are continuously running at peak operating capacity. They're looking for a way to reduce outages, and they want to prevent performance problems from happening. Application developers, on the other hand, they want self-service tooling in development and QA environments. And finally, application support staff. These are people who are responsible for making sure that issues are fixed and even avoided if possible. They want faster time to repair, and they want to find the root cause of application issues faster.
Thanks for the explanation. Can you give us some examples of how people in these roles use meshIQ for Kafka management and observability?
Sure. Let's talk about a few use cases so that our audience can see how meshIQ works in real situations. Let's start by looking at shared services, where administrators are responsible for the governance of Kafka. In the meshIQ solution, the user interface is composed of a selection of dashboards, and each of these dashboards contains one or more views which contain displays of information related to objects selected from the mesh. This interface is completely customizable by the user. For example, a user can create or modify and delete the dashboards and their views. You can change the search criteria and the display options of each view. And you can also create user perspectives to organize a set of dashboards that are related to the same theme. In addition to custom schemas that control the set of attributes to be displayed, each view provides a set of filters that are based on search criteria. This allows the user to control the list of objects to be displayed. In this way, the interface is governed by search with options that help the user to find and focus on the objects that they need to work with. This is a real benefit in terms of ease of use. One of the techniques that's commonly used in troubleshooting problems involves comparing objects to ensure that they're properly defined. For example, an administrator may want to compare the attributes of topics selected from one or more clusters to examine their differences. The administrator can open a property sheet for a selection of multiple topics and make changes to specific attributes. In this example, we're looking at the properties of several selected topics from one or more Kafka clusters. Notice here that some of the attributes are highlighted in blue. That's because these blue fields contain different values across the selected objects. Let's look at another use case. Application developers build business workflows that depend on Kafka event streams. They need a fast and easy way to test their code. Ideally, they want a self-service capability in testing environments to view and manage Kafka topics and messages. But administrators want to control and audit that activity. meshIQ simplifies object-level security with high granularity by assigning role-based permissions to groups of users and applying those permissions to groups of objects. Administrators can set up dashboard templates that can be shared with DevOps teams, with object filtering and context-sensitive menus that enable these teams to do their jobs. The actions that these users can perform and the objects that they can view or manage are dependent on their authorizations. There's a compelling set of features for message management that's useful for application developers. The interface makes it easy to manage messages on Kafka topics. Users can view messages, load messages from files to topics, and copy and paste messages between topics. The solution provides powerful features for criteria-based search of messages. For example, search criteria based on character strings can be used to search messages that contain business data, such as orders or invoices. The solution keeps a full audit trail of all configuration changes made to every Kafka object, and administrators can consult the event details for every change, what changes were made, when the changes were made, and by whom. The audit report can be filtered by user, object type, object name, type of access, and time and date. In addition to self-service, there are more and more organizations that are building CI/CD pipelines with automation tools like Ansible. Well, automation playbooks are great, but it's sometimes challenging to use them to manage the full application stack. And for that reason, meshIQ provides a REST API that's simple to use across all middleware from on-premise to multi-cloud implementations. Now, this REST API can be used in conjunction with automation tools to provision and update Kafka resources. And it uses the same role-based access control and object-level security features that apply to our web interface. meshIQ provides real-time observability in application context so that the right people in your organization can get timely alerts about Kafka issues. Data points are collected from Kafka clusters across your enterprise network to create a catalog of live runtime metrics and events. Using a graphical editor, you create rule-based monitoring policies that define the conditions for alerting based on observability. There is no scripting or programming required. These monitoring policies provide notifications and alerts about detected situations according to their level of severity: informational, warning, error, or critical. It's very easy to create powerful monitoring scenarios with very little effort. The solution includes pre-built, out-of-the-box monitoring policies that are designed to handle the most common situations you'll encounter. And you can modify and extend these pre-built policies or build your own. With each sampling of data, meshIQ uses machine learning to perform continual statistical analytics. This enables the detection of trends and patterns within the data that we can use to identify situations of interest that we wouldn't normally notice. This gives us an early warning system to detect degraded performance, unusual activities, and anomalies. Many organizations have high-profile business workflows that are dependent on Kafka event streams and are subjected to very demanding service level and audit requirements. They have to keep a consistent account of indicators of things like throughput and request latency and other metrics. For all of these reasons and more, organizations today are looking for better observability of what's happening within the messaging and event streaming infrastructure. The meshIQ solution provides analytics of time series data that give you insightful views that are intuitive and easy to interpret, so that people get better understanding of what was happening during a selected time interval, like the last 45 minutes, or the last 5 days, or between two timestamps. The benefit is that you don't have to figure out what happened during a given time period using various logs or monitoring tools, since the needed analytics are all in one place. To make dashboards with visualizations like these, the meshIQ solution provides an easy-to-use querying language for analyzing time series data. And there's also a convenient query editor that enables you to create these graphical views by filling in a form. These dashboards help users to get answers to their questions in a way that's readily understood. Another area where meshIQ provides exceptional value is tracking and tracing of messages and application message flows. For example, message tracking provides visibility of the messages that are produced and consumed on Kafka topics. We can keep track of the number and volume of messaging events that happen during a selected time interval. We can summarize data, like the counts of messages. By clicking on any view in our dashboard, we can drill down into the details of every messaging event to see the time at which each message was streamed to a Kafka topic, the partition and offset, the size of the message, and even the content of the message. By parsing message content, we can extract details like invoice numbers or regional office codes or product divisions. And we can also aggregate the data contained within messages, like sums of orders or invoices or payments. Message tracking can actually show you which parts of your business are performing well and which areas require your attention. Many organizations find it challenging to find out why business workflows sometimes deliver inconsistent performance. Often, they turn to application performance management or log analysis software to get help. But without visibility of what's going on inside the mesh, these organizations have a blind side that prevents them from seeing the full story. Application message flow tracking gives you visibility of how applications interact with the mesh to produce and consume messages. Application message flow tracking can help to identify specific problem areas in your business workflows, like bottlenecks in message processing and event streaming. meshIQ keeps track of the elapsed time of each message flow, as well as event counts and the timings of each event, and provides graphical charts that you can visualize workflow performance over time. Business workflows like these are often tied to service level agreements. For example, most organizations expect business workflows to complete within a certain time limit, which can be measured in milliseconds. meshIQ keeps track of the workflows that are meeting those SLA criteria and those that are not. With meshIQ, you can set up service level objectives for message flows. For example, you can specify objectives for the elapsed time of workflows or completion codes, or objectives based on data parsed from messages. You can perform root cause analysis. For example, the solution uses machine learning to determine normal behavior of message flows belonging to the same set. And also, the meshIQ solution provides alerting in situations where the service level objectives are not met.
Wow, I'm really impressed. The meshIQ platform is really a complete solution for Kafka observability and governance. I would really like to try it out myself.
Thanks, Jess. It really is a complete solution. And for everyone who would like to try it out, here at the Kafka Summit London, we're making an important announcement today. We're announcing the availability of meshIQ Cloud. meshIQ Cloud is software as a service hosted and managed by meshIQ. It requires no installation of software in the customer environment. It works with a monthly subscription, and we offer a free 30-day trial. You can sign up for meshIQ at this website, https://www.meshiq.io.
Thank you, Scott. We will now open up the floor for a Q&A. We have already had a lot of questions come in, so let's get started. First question for Scott. Does meshIQ work for all distributions and versions of Kafka?
Yes, you can use the meshIQ solution with all distributions of Apache Kafka. Open source Kafka, the Confluent platform, Amazon MSK, IBM event streams, and more.
So moving on to the next question. There are a lot of software vendors who propose tools for Kafka. What makes the meshIQ solution different from other products on the market?
Actually, meshIQ delivers significant added value in comparison with other tools for Kafka management, monitoring, or analytics. The first point is that meshIQ is a complete solution for Kafka. It delivers governance with things like configuration and message management, secure self-service with role-based access control, and highly granular object-level security. There's intelligence with real-time monitoring, with proactive alerting, and trend and pattern detection. And actions, automated actions that are based on events. Finally, introspection, performance analytics that are based on time series data, as well as tracking and tracing of application message flows. All of these functions are included in one holistic software solution. I can't think of any other product on the market that encompasses such a diversified and valuable suite of capabilities in a single offering. And another important differentiator is that meshIQ is not only a solution for Kafka. It offers the same set of capabilities for multiple messaging and event streaming technologies like IBM MQ, TIBCO EMS, RabbitMQ, ActiveMQ, Solus, PubSub Plus, and many more.
Here is the next question. Does this solution require installation of any software on the managed Kafka clusters or brokers? Are any changes required to Kafka?
No, meshIQ does not require installation of any software on the managed endpoints. There's no changes required to your Kafka clusters or brokers. meshIQ manages communication with Kafka and other technologies within the mesh using existing communication paths. For example, for Apache Kafka, the meshIQ data plane connects to the Bootstrap server of a Kafka cluster and issues management commands and receives replies.
The next question that came in is, I have some concerns about the performance impact that monitoring and analytics can have on the Kafka infrastructure. What is the estimated overhead of your solution on Kafka?
Well, with each release of our software, we do rigorous performance testing and benchmarking to ensure that the impact of observability to Kafka and other messaging and event streaming technologies is minimized. Now, one reason for this is that we use an agentless architecture for capturing data using standard built-in APIs. And all of the components of the meshIQ solution that produce analytics are hosted on separate dedicated servers. Our benchmarks show that in most cases there's less than a 2% increase in terms of CPU consumption and memory on monitored nodes. For message tracking and application message flow tracking, our performance benchmarks show that for each intercepted messaging event, the overhead is less than 50 microseconds.
So moving on to the next question. What deployment options are available? Is on-premise deployment an option? Is container-based deployment an option? Is there a SaaS option?
We provide several options for deployment of meshIQ. For on-premise deployments, we ship a deployment pack in the form of a compressed file with configuration parameters for personalized installation that's accomplished in literally a few minutes. For containerized deployment, meshIQ can be deployed using Docker as well as Kubernetes. It runs on the container services of popular cloud-hosted environments like Amazon Web Services, Azure, Google Cloud Platform, and Red Hat OpenShift. And the solution can also be run directly from the meshIQ cloud, where it runs as a SaaS solution.
The next question we received is, how is scalability achieved with this solution?
Okay, so a question about scalability. Well, as part of the microservices architecture of meshIQ, we have a control plane that includes a central container that we call a SEP engine. That stands for Complex Event Processor. This SEP engine provides observability and control of Kafka and other messaging and event streaming technologies across the enterprise network. Now, depending on the number of endpoints to be managed and the size of your environment, you'll have one or several of these containers at runtime. If your messaging and event streaming environment increases in size and complexity, you simply add more of these containers to cover the scope.
Okay, so the next question. So in your demo, you showed that meshIQ can view and parse the content of Kafka messages. But in our organization, we don't want our users to see the full content of messages because some information is confidential. Can your software hide the parts of the messages that we don't want our users to see?
Absolutely. We can show all of the message or just selected parts of the message or none of the message, depending on your requirements and your rules for confidentiality and security. Message extraction and parsing is controlled by simple rules.
The next question that was sent in is, in your demo, it sounded like you made a distinction between message tracking and application message flow tracking. For Kafka, is there a difference between those two concepts?
That's true. I did make a distinction between the terms message tracking and application message flow tracking for Kafka, and I'll explain what I mean. In the case of message tracking, we're principally interested in the messages that are produced and consumed on Kafka topics. So that means capturing the details of each message that's written to a Kafka topic and then rendering information about each message to the user. And also aggregate and summary information about messages over a selected time interval. And finally, being able to find messages that are based on search criteria. Now, application message flow tracking offers the same information, the same benefits, but it extends observability to the applications that produce and consume those messages on Kafka topics. With application message flow tracking, we get the added benefit of seeing which applications produce the messages and which applications consume the messages, as well as the sequence and the timings of these messaging events from an application viewpoint. The meshIQ solution provides both message tracking and application message flow tracking.
It looks like we have time for one more question. How much time is required to deploy meshIQ, and how much time is required to become efficient in using it?
Well, installation of meshIQ takes just minutes to accomplish, and it only takes a few minutes to configure connections to your mesh. We have a customer resource center website that provides tutorials and videos that show you how to use the product, and user documentation is provided on that site as well. Most users can become well acquainted with the principal functions of the product within a couple of days of usage. Now, acquiring real proficiency with the solution takes more time, of course. We have a professional services organization that provides assistance in deployment and also education services.
I want to thank everyone for joining today, and if we were not able to answer your questions today, please reach out to us and we'll be happy to address it. We will have this Tech Talk available on demand, posted on the meshIQ website following this call at www.meshiq.com. Also, please note, this webinar is part of a series of Tech Talks. We rotate the topics and really try to focus on different middleware technologies. We would love to have you join again, so please be on the lookout for our next upcoming webinar. You can find upcoming events on our website. I wanted to thank Scott for presenting this Tech Talk, and thank you again to all who joined in today. Have a great rest of your day.